Refraction of light. We know that light travels in a straight line path. This is true as long as light rays are traveling in the same medium or same substance having the same density throughout. If, however, the light rays are made to go from one medium to another, the light rays change their direction at the boundary between the two media. For example, when a ray of light traveling in air goes out obliquely into another medium, for example glass, it changes direction on entering the glass block. The change in direction of ray of light or bending of ray of light occurs again when it goes out from glass into air. The change in direction of light when it passes from one medium to another obliquely is called refraction of light. In other words, the bending of light when it goes from one medium to another obliquely is called refraction of light. The refraction of light takes place when light rays enter from air into glass or from glass into air. The refraction of light takes place when light enters from air into water or from water into air, and the refraction of light also takes place when light enters from water into glass or from glass into water. The optical instruments like camera, microscope, telescope work on the refraction of light through glass lenses. The refraction or bending of light takes place at the boundary between the two media. The angle between incident ray and the normal at the point of incidence is called as angle of incidence. The angle between the refracted ray and the normal at the point of incidence is called as angle of refraction. The angle of refraction is usually not equal to the angle of incidence in case of refraction. The angle of refraction is either smaller than the angle of incidence or greater than angle of incidence in case of refraction. Cause of refraction. The speed of light is different in different media or substances. For example, the speed of light is 3 into 10 raised to 8 power meter by second, whereas that in case of glass is 2 into 10 raised to 8th power meter by second. It is clear from these values that the speed of light is more in air but less in glass. In other words, light travels faster in air but slower in glass. The refraction of light is due to the change in speed of light on going from one medium to another. Thus, when light goes from one medium to another, its speed changes, and this change in speed of light causes the refraction of light. The refraction of light on going from air to glass takes place because the speed of light is different in air and glass, being more in air and less in glass. So, when light enters from air into glass, its speed changes, and this change in speed of light is going from air to glass causes the refraction of light. Please note that the greater the difference in the speeds of light in the two media, greater will be the amount of refraction or bending of light. Why a change in speed of light causes refraction of light? The refraction of light or change in direction of light on going from one medium to another can be explained by using a wave theory of light. A beam of light is made up of tiny waves. When a beam of light consisting of light waves and traveling in a certain medium falls obliquely at an angle on the boundary of another medium, then one part of the light waves enters into other medium first and its speed changes first, but the rest of waves enter other medium a little later and hence its speed changes a little later. The fact that the speed of light waves on one side of a beam of light changes a little before the change in speed of light waves on its other side causes a change in the direction of light. And this change in direction of light is called refraction of light or bending of light. This will become more clearer from the following example, in which a beam of light is entering from air into glass slab obliquely and then emerging into air from its other side. Light waves travel faster in air but slower in glass. When a beam of light consisting of light waves and traveling in air falls on a glass slab obliquely, then the part of the light waves on the left side of the beam of light reaches the glass slab first and slows down first on entering the glass. The rest of light waves on the right side of the beam of light are still in air and have to travel more distance in air before reaching the glass, and hence slow down a little later on entering the glass. Since the speed of light on the left side of the beam is reduced a little before its right side, therefore the direction of light changes on entering the glass. Please note that the decrease in speed of light waves on going from air into glass causes bending of light towards left side towards the normal. When the beam of light traveling in glass slab comes out into air obliquely at an angle, then the part of light waves on the left side of beam of light emerges out into air first and speeds up first. The part of light waves on the right side of beam of light emerging out into air a little later, and hence its speed increases a little later. Since the speed of left side of the beam of light increases a little before its right side, therefore the direction of light changes on coming out of glass slab into air. An increase in speed of light waves on coming out from glass into air causes bending of light towards the right side. When light waves move from air into glass, their speed decreases and their wavelength also decreases. On the other hand, when light waves come out from glass into air, their speed increases and their wavelength also increases. Before we discuss the refraction of light in detail, we should know the meaning of the terms optically rarer medium and optically denser medium. Optically rarer medium and optically denser medium. A transparent substance in which light travels is known as a medium. Air, glass, certain plastics, water, kerosene, alcohol are all examples of medium. Different media are said to have different optical densities. A medium in which the speed of light is more is known as optically rarer medium. Air is an optically rarer medium as compared to glass and water. A medium in which speed of light is less is known as optically denser medium. Glass is an optically denser medium than air and water. Now the speed of light in water is 2.25 into 10 raised to the power of 8 meter by second, which is less than that in air but more than that in glass. So water is optically denser medium than air, but it is optically rarer than glass. Please note that the refraction of light takes place whenever it goes from an optically rarer medium to an optically denser medium, or from a denser medium or a rarer medium. The optically rarer medium and optically denser medium can also be defined on the basis of their refractive index. We learn this after a while. Keeping the above discussion in mind, we can now write down two rules which give the direction of bending of a ray of light when it goes from one medium to another. When a ray of light goes from a rarer medium to a denser medium, it bends towards the normal. When a ray of light goes from denser medium to a rarer medium, it bends away from normal. Refraction of light when it goes from a rarer medium to a denser medium. When a ray of light goes from air into glass, it bends towards the normal at the point of incidence. In this case, the angle of refraction is smaller than angle of incidence. When a ray of light goes from air into water, it bends towards the normal. Thus, the refraction of light on going from air into water is similar to the refraction of light from air into glass. Refraction of light when it goes from a denser medium to a rarer medium. When a ray of light goes from glass into air, it bends away from normal at the point of incidence. In this case, the angle of refraction is greater than the angle of incidence. When a beam of light is traveling in water, enters into air, it bends away from normal. When a ray of light goes from a rarer medium to denser medium, its speed decreases. And when a ray of light goes from denser medium to a rarer medium, its speed increases. The light emerging from a parallel sided glass slab in a direction parallel with that in which it enters the glass slab. The perpendicular distance between the original path of incident ray and the emergent ray coming out of the glass slab is called lateral displacement of the emergent ray of light. Lateral displacement depends mainly on three factors. There is angle of incidence, thickness of the glass slab, and refractive index of glass slab. Actually, lateral displacement is directly proportional to angle of incidence, thickness of glass slab, and the refractive index of glass slab. Higher the values of these factors, greater will be the lateral displacement. Another point to be noted is that in this case, the refraction or bending of light takes place twice. First, when the light enters from air into glass, and then when the light goes out from the glass into air. The angle which the emergent ray makes with normal is called angle of emergence. Light falling normally or perpendicularly on a glass slab. If the incident ray falls normally or perpendicularly on the surface of a glass slab, then there is no bending of light ray and it goes straight. We can explain the case of no refraction or no bending of light on going perpendicularly from air into glass as follows. When a beam of light consisting of light waves and traveling in air falls perpendicularly to the surface of the glass slab, then all the parts of the light waves reach the glass slab at the same time, enter the glass slab at the same time, and hence get slowed down at the same time. Due to this, no change in direction of light takes place. In other words, no refraction of light takes place. Similarly, all the parts of the light waves of the beam of light traveling in glass slab come out of the glass slab into air at the same time and hence speed up at the same time. Due to this, no bending of light occurs when the light waves go out from glass slab into air. If a ray of light falls normally or perpendicular to the surface of water, even then there is no bending of light ray and it goes straight through water. Effects of refraction of light. The refraction of light produces many effects which can be observed in day to day life. For example, a stick or a pencil held obliquely and partly immersed in water appears to be bent at water surface. An object placed under water appears to be raised. A pool of water appears to be less deep than it actually is. When a thick glass slab is placed over some printed matter, the letters appear raised when viewed from the top. A lemon kept in water in a glass tumbler appears to be bigger than actual size when viewed from the sides. The stars appear to twinkle on a clear night. All these effects are produced by the refraction of light or change in direction of light when it passes from one medium to another. A stick partly immersed in water appears to be bent at the water surface. When a straight stick is partly immersed in water and held obliquely to the surface, it appears to be bent at the point where it enters water. This apparent bending of the stick is due to refraction of light when it passes from water into air. Let us understand it more clearly. When a pencil is partly immersed in water and held obliquely to the surface, the pencil appears to bend at the water surface when viewed from side. This apparent bending of the pencil is due to refraction of light when it passes from water into air. We can use the object placed under water appears to be raised. When the coin is placed under water and the rays coming from coin travel in water in straight line paths until they reach the surface of water, when the rays of light traveling in water go out into air, they get refracted. The ray of light gets refracted at point and bends away from normal and goes in direction which is different. Similarly, a ray of light gets refracted at another point and bends away from normal and goes in different direction. Thus, when the coin is under water, then due to refraction of light, a virtual image of coin is formed nearer to the water surface. And since the virtual image of coin which we see is nearer to the water surface, so the coin appears to rise on adding water in the basin. Thus, it is due to the refraction of light that a coin placed at the bottom of a container appears to rise as the container is slowly filled with water. If instead of water we take some other transparent liquid such as kerosene or turpentine in the above experiment, then the bending of stick or raising of coin will appear to take place by different amounts than that in water. This is because light is refracted by different amounts in different liquids. A pool of water appears to be less deep than it actually is. If we look into a pool of water or tank of water, it appears to be less deep than it really is. This is due to refraction of light which takes place when light rays pass from pool of water into air. When we look into pool of water, we do not see the actual bottom of the pool. We see a virtual image of the bottom of the pool which is formed by refraction of light coming from the pool water into the air. And since the image of the bottom of the pool is formed nearer to us, we feel that the pool is less deep. From this discussion, we conclude that bottom of pool of water appears raised due to refraction of light and the pool of water appears to be less deep than it actually is. We should be careful while entering a swimming pool because the water in it will be deeper than it appears to be. It is also due to refraction of light that a thick glass slab appears to be less thick when seen from above than it actually is. Similarly, an ink mark or the writing on a piece of paper appears to be raised and much nearer than it actually is when viewed by keeping a glass slab over it. This also happens due to refraction of light, as we will study in the next chapter. The stars appear to twinkle on a clear night due to the refraction of light in the atmosphere. Before we go further, we can discuss the laws of refraction of light.